So, all the projects I make are not for you guys. Sometimes I like to make things for myself. So what I thought I'd do this week is to show you guys one of the projects I'm working on, and let you look over my shoulder as I build it. Do something a little different for a change. My son and I, a while back, decided we'd like to try a little long-range shooting, so we bought some Browning A-Bolt 3 rifles. I bought a 300 Winchester Magnum, and he bought a 7mm Magnum, and we got scopes as well. And the scope I chose, as it turns out, the body, the 30mm body, is too large for any of the commercially available scope mount rings. I like one-piece rings, especially since we're going to be shooting out to anywhere from 600 to 1,000 yards. I feel that solid one-piece scope rings would be a better option than the two-piece ones that mount on a rail. So I designed up a set of scope rings to fit my rifle and fit the scope I bought. And I used, normally I do my work in SolidWorks. I get a lot of questions on what CAD system I use, and I do use SolidWorks, but I'm able to use it because I can bring a copy home from work to use. I'm allowed a seat at home. It is a commercial, professional CAD system, so it runs about $4,000 a seat. So it's a little pricey for home hobbyists. But just for fun, I came across this 3D CAD program called Onshape. It's invented by the same guy that first invented SolidWorks. So it's a lot of the features are similar. The difference is that it's a cloud-based CAD system. Everything you do is on the cloud. You don't have to have a program. You don't have to have a supercomputer to run it. You can even do it from a smartphone or a tablet. So I started playing around with it a little bit, and it's pretty powerful. It lacks a little bit of functionality right now, but it's new. I'm sure they'll bring a lot more to the table once it's been around for a while. But I drew up these, or I modeled up this scope ring, these scope rings. I don't know if you can see them. And it did a pretty good job. All the necessary features are there, functions. So anyway, thought I'd build up this set of scope rings today, or this pair of scope rings, and let you guys look over my shoulder, just for a little change of pace. So to start out with, I already got the stock squared up, the two pieces. Figured I wouldn't bore you with that. I've done enough stock squaring videos, so I skipped that. But basically, the only thing I did a little different is, since I am making two sets of these, when I do that, I like to leave the stock in a long piece and square up four sides, square up each end of the long piece, and then just slice off what I need. In this case, two pieces. Just slice it in two, set it in the vise, and then take one more pass on the end. It saves a little time, less parts to handle in the vise, makes it a little easier to manipulate. So that's about the only thing I did different than normal squaring. So next thing I want to do is I want to drill the mounting holes in these things. We got an upper and lower ring. So I want to drill the mounting holes, screw the things together, then I'll do all the machining with them assembled. So next thing is I got to drill some counterbore holes in the top piece and some tapped holes in the bottom piece, and I guess that's what we'll get started with. Let's get going. Okay, so I got the clamp rings, stock for the clamp rings. You have to drill and counterbore 4 holes in it. This part's, the dimensions are pretty close on the length or the width and height. So I went through, and I always like to put marks on the side that the holes belong on, so I don't get them on the wrong side by mistake. It's always a good thing. I always keep a Sharpie close at hand for doing calculations or whatever on the vise, or putting witness marks on the parts. It's always a good thing to do. So get the part in the vise, and I'm working down on one end, so I like to use the other part to balance out the vise so the jaw doesn't cock when you tighten it down. So let's pick up the edges of the part, the X and Y, find our 0 point. Pick up the front edge, zero out our dials or our DRO. Remove over half the diameter of the edge finder, so that puts us even with the front edge. The holes are centered on the length of the part, so I'm going to, rather than work from the edge, I'm just going to work from the center. Pick up each edge and hit our 0 point in the center, halfway between. Okay, I hope you guys can hear because I'm not using my lapel mic today because it's such a pain to do the editing. So since I'm working on my own stuff here, I'm going to skip a few corners, cut a few corners. Hopefully you can still hear okay. Alright, so this is a number 6 hole. It's got a 141 diameter through, so that's a number 28 drill. And holes are 135 thousandths up from this front edge. About there, and they are 1.440 apart, so that's 720 each side of center. Just about there. Looks about right. These are through holes. You get some WD-40 for lubrication. And they are 390 thousandths apart. So I zeroed out my DRO and I moved 390 over. Right there. Yeah, I'm touching the drill with my finger. I'm sure I'll get a lot of complaints about that, but that's what I do. Been doing it for years. A lot easier than fooling around with brushes. You have to drill a hole in my finger, so I guess it's pretty safe. Alright, 720 this way. Okay, so I missed the fact that the battery went dead in the camera because I'm not paying much attention to it. Sorry about that. But got these parts drilled and counterbored, good to go. So next thing we do is put the corresponding tap holes in the base. So let's get going on that. Okay, these hole patterns are the same as in the clamp ring, the upper part, so we'll make them basically the same way. Using one as a spacer and one against the stop here. And we have to pick up the front this time. We find the front again because this part's wider than the other one. Let's do that. And move in the 135 thousandths. The X location's the same, so I don't have to touch that. So it should be good to go. This time I'm doing a 632 tapped hole. Through on the part works out to, I don't know, a little over a 1/4 inch deep, so I'll go deeper than that. Go deeper than that because when the profile of the part is milled, the hole will come through then. I just want to have enough depth to it so it's easy to tap. 632 tap is a number 36 drill. And our hole spacing between in the long direction is what? 1.440, so that's 720 each side. Speed this back up again. I had it down low for the counterboard. That ought to be deep enough. I'm going to power tap these, so I want lots of room for chips. Alright, then the distance apart is what? 390. Out there. tap drill. Now I could power tap it while it's all set up here. I think I'm just going to hand tap it with the cordless drill. Still power tapping, but I'm going to use a cordless drill rather than the mill. If you're new at this sort of thing, I would advise you not do that, because it requires a certain amount of experience to get the tap started square. I've done this enough that I can get it started dead on. So I have to worry about the tap going off axis or in on an angle. Basically, just look at it from each direction, make sure it's square. Square to the part in both directions. Just power tap it in. WD-40 makes a great tapping fluid for aluminum. One. Like any power tapping, you got to make sure and get the tap into the chuck tight enough that you can spin it, and not so tight that if it bottoms out, you break the tap. Got to be left, be able to slip a little bit if it bottoms out. Again, if you're new to that, new to power tapping, practice in some scrap parts. Don't scrap out a real part learning how to power tap. All right. Always make sure you're wearing safety glasses when you're using compressed air or machining in general. Alright. Some socketed cap screws here. Let's screw these babies together. Keep from dropping them all on the floor. I'm going to leave them loose, put them in the vise to make sure everything's well aligned before tightening them down. So there is a certain amount of play in the through holes. So just make sure everything's lined up on both axes and tighten them down. So there's a scope, start of a scope ring anyway. So what do I want to do next? I think probably next we'll bore the hole in a 30 millimeter diameter hole centered on this parting line. So let me get it set up for that, and we'll bore some holes. Okay, so got to put a 30 millimeter hole on this parting line, centered up. So let's find the location. Is that close enough so you guys can see? Yeah, I guess it is. Centered in this direction and wide. Right there. And in X it is 716 thousandths from this edge, according to the print. I will post these prints on the Tom's Techniques website, just so you can, I don't know if anybody will ever need to make a set of these, but if you do, they'll be there. If you just want to look at them and follow along as I build it, you can do that as well. Like I said, this, if you have a Browning A-Bolt 3 and you want to put a 30 millimeter scope on it, this is the only option if you want a one-piece ring. So it'll be up there. If not, that's okay too. Alright, so I can't drill this because it's right on the edge of this higher piece sticking up, so I'll have to use an end mill. And this is the biggest usable 2-flute end mill I have at the moment. It's 13/16, so we'll use that one and punch a hole through it. And then we can switch over to a boring bar and bore it out to size. I'll lock both axes now because this milling on the edge of a part like this might move my cable in the X dimension. So I'll lock everything down and just drill through. Just like that. of chips, a lot of chips. Alright, so we could switch over to the boring bar and do that same piece, but it's easier since we're all set up here just to switch parts. Do a little semi-production. One step at a time on each part. Chips are sticking to the tool as it gets heated up, so we'll use some oil and slow it down a little bit. There we go. This tool's been, sand mill's been sharpened a few times, so it doesn't have the original geometry. I think the original one probably had a little more clearance. It wouldn't load up like that. Got the job done. Alright, so let's get the boring head put in. Another thing on my list of things to do is to get this darn power drawbar back in operation. I bought another Harbor Freight impact wrench for it. Hopefully this one will last longer than the first one. I thought about redesigning the whole thing for a better quality impact wrench, but it's a lot of work. And darn things are only $19, so I can afford to replacing one or two of them. Alright, I'm not sure what's up with these batteries today, but camera seems to be going through pretty fast. May have to break out the power supply for it. So anyway, we got this bore finished. I don't know if you can see it. Turned out pretty nice bore. Focus camera. Why are we not focusing? There it is. Huh. Alright, anyway. That bore's the size, so let's throw the other one in, do the same thing. We're all set now, so I can just go ahead and bore it to size. Nice thing about a boring bar like this is it always deflects to the inside of the hole, so if you take a heavy cut like this and then a couple spring cuts, it'll be right to size. You can see the spiral of the tool dragging when I pulled it out there, right? So now we're going to go back through without resetting the position at all, and we'll take that last little bit of stock out. And hopefully it'll be right at 30 millimeters, which we'll check here in a moment. Okay, we should be at 1.181 inches. Let's check it. One point one 1805. So we're half a thousandth under, which is perfect. I'm gonna leave it right there. All right, starting to look a little bit like scope rings. So next thing I'm gonna do, I think, is put the two mounting holes. Two holes that go in the bottom of the bore to screw the scope mounts to the receiver and the rifle. So I think I'll put those in next. All right.